Welcome to another video on SVP Electronics. In this video, I'm going to be showing you how to create a robotic car controlled by a Stadia controller, and it has an arm on top. This includes an ESP32, a stepping motor, lots of drivers, 4 car wheels, and 2 servos. This video will have the full tutorial and the demonstration at the very end. It also has all the lessons I learned during this project. So first, I'm going to show you how to use these components separately. So first, I'm going to start off with the car or the 4 motors. So at the top here, we have the blue pad library, which connects the ESP32 to the controller. And then below that, we have the pins. So I'll go into this in more detail later on. And then below that, we have the channels. So this is for the left side and this is for the right side. And then this is the set motor speed. And then the dead zone is so that if you move the controller a little bit, it won't move, but you have to move it to a certain limit for it to start moving. And then below that, the next important part is the void setup. So here you do the pin modes, so IN1 to output, IN2 output, and so on, so on. And then here's for the channels. We set the channels frequency and their resolution. Don't change this unless you know what you're doing. And then up here we have the process gamepad. So here we have the throttling and the steering, so X is to X and Y to Y. Then here we put the dead zones into their place, and then below that we have the steering for it to go right and left, otherwise it won't go right and left. So here you do the fixed 100 speed going forward, and then below that you do the digital write, so you write to it. And then this part you enable the pins, so you enable the channels which we set down in the voice setup. And that's it for the car. So next thing we're going to do is look into the code. So I said I'll come back to this part, so I'm going to come back to this part. So this is the wiring for the 4 car wheels. So ENA pin to pin 32, IN1 pin to pin 26, IN2 pin to pin 27, IN3 pin to pin 21, IN4 pin to pin 22, ENB pin to pin 33. So this is for the 2 car wheels on the right, and this is for the 2 car wheels on the left, and this is for the left 2 motors, and this is for the right 2 motors. If you look into the power, where the arrow is pointing now is where the 12 volt comes from an external supply, and then just below that, where the arrow is pointing now, is where the external GND and the common ground with GND to the ESP comes in. And then you connect the positive to the motor to where the arrow is pointing now, and the negative to the motor for where the arrow is pointing now, and you do the same thing on the other side. So now let's look into the servers. So I'm using 2 servers for this project, a 9G server and a Hitec server. So let's look into the Hitec server first. So at the top here I have the ESP32 servo library for the Hitec server and the 9G server. So I do the servo command and the servo name after the server command from the ESP32 library. I name the 1 and 2. So server Hitec is pin 13 and server 9G is pin 2. And then I create the servo pos variable just for servo 1. Okay, so as we go down to the void setup, where everything gets set up, we allocate the servo 1 and servo 2 to their set channels. So channels help because there's communication, and then the communication will cause the servos to jitter and maybe even smash your project into pieces. So I allocated servo 1 to channel 3 and servo 2 to channel 2. So now let's go to the process gamepad. So for the servo 1, I'm using the RY axis, which is the right side of the controller Y axis. So I'm using dead zones for this as well. So if you go to the servo part of the code, you can see that I'm using increments as it goes up, and then it constrains it to 0 and 170 for safety. So the servo doesn't crash or get damaged. And then that's it for servo 1. For servo 2, down here, we're using the D-pad because it's much easier and it's only for grabbing, and then we don't need to set it to certain positions. So I've worked this out using my 3D printer, which I've used to create a claw and a plunger, so the claw can be pulled up. So servo 2, when it gets pulled up, it's set to 150 degrees at an angle, and then servo 2, when it gets pushed down, it gets moved to 15 degrees. That's it for the servos. Now let's look into the wiring. For servo 1, I have a whole other video on this, so you guys can check it out. But for servo 2, it's very simple. Just connect the signal pin to pin 2 on the ESP32, and then the power pin to 3.3 volts on the ESP, or if you have 5 volts on the ESP, and then the brown pin or the black pin or the GND pin to GND on the ESP32. So now let's look into the stepper part. So the first part we're going to look at is the pins part. So I'm using a Nema 17 and a TB6600 driver. So step pin to pin 18, DIR pin to pin 19, EN pin to pin 23. And then at the bottom in the void setup, we have the pin mode, so all of them are set to output, and we set EN pin low so the driver can activate. So now if we go to the process gamepad, we're using the RX, so the right X-axis joystick for this, and then we set the dead zones, and then near the bottom of the process gamepad is where everything happens. So at the top part, it checks if RX has been moved, and then after that it checks which direction it goes in, and then below that it maps it, so if you, depending on how far you push it, that's how far it's going to move. And then after that is checking if it's stepped, so it can send the next step. And then here it sends the information, it sends a pulse so the step can go past. And now we're going to go into the wiring. So the wiring for this is quite simple. So the step pin or POL plus goes to pin 18 on the ESP32. The DIR plus goes to pin 19 on the ESP32. And the EN plus goes to pin 23 on the ESP32. And then the EN minus, DIR minus, and pull minus all go to the same GND combined. And then for the power, the 12 volts come in from an external supply, goes to the VIN, and the GND comes in and goes to the GND on the driver, and then it goes to the ESP32 to a common ground. And finally, you connect the two coil stepper motor pairs to A minus, A plus for one pair, and B minus, B plus for the second pair. And here's a quick image for the switches that I done. So 1 is down, 2 is down, 3 is up, 4 is down, 5 is down, and 6 is down. Now let's get into the main part of this project. So during this project I learned many things, and I'm going to tell you all the things that I needed to do to get to this stage so you don't make the same mistakes that I did when I was going through this project. The first thing I did was very easy. It was just getting the 4 car wheels working with the L29AN. So the next thing was a stepper motor, which was a big challenge for me. I went through 2 drivers, A49AA and the DRV8825, and both of them failed me, and then I came to know about the TB6600, so I gave that a shot and it started to work. Now I've got that working, I need to get my servo working. As I said before, I'm using a Hitec Servo, so this needs an external supply. So for this I used a buck converter. But when I used the buck converter, I couldn't use the car, the stepper and the servo all at once because of interference. So I dived deeper and realized that I needed to add channels. So I added a channel and then it started to work. And then after that I accidentally busted my ESP32 and my servos. So I had to get new ones and then see what I'd done wrong and made sure that never happened again. But then my buck converter power was too low, so I had to get an adjustable one so I can adjust it to a higher voltage. Now I'm one step closer to finishing this project. The next thing I needed to do was combine my 9G server to all of this. This was very simple. All I had to do was use the ESP32 3 volts and attach it with the GND and the signal pin. That was very simple and easy to do, except that I busted it once and I replaced it. Now it's time to get printing. For this whole project I used an 85X 3D printer and a FlashForge Finder. My FlashForge Finder is 9 years old, so I had to replace it with an 85X later on in this project. You can see from my time lapse that this 85X printed a lot of my things, like the claws and the arms and all of that. And the STLs will be in the description once I get all of them combined in one file, and the description will go to a MakerBot link where you can download it from. Now I've put it all together, let's see it in action. Thanks for watching, guys. I hope this tutorial helped you. If you need any help, please join my Discord group or tell me in the comments and I'll try to help you. Also, do look on GitHub and Makerbot to get the STL files. Thanks for watching.